Welcome to SanfordFlipMath. This is PreCalculus. We are doing work in the Demana Foley Kennedy book. And this section that we're going to work with here is just actually a little snippet of the section 7.3, which deals with solving systems. And we are only going to work with solving systems using inverse matrices. And we are only going to work with solving systems using inverse matrices in the calculator. In this section, there is in other years other than 2013, we might add in some other things, so I have to be careful how I say things because this video might get used in another year. But in 2013, we're going to be just working in the calculator in interest of time. We are not going to be finding inverses by hand or determinants by hand, whatever that is. Those are topics that were dealt with in Algebra 2 and are traditionally dealt with in PreCalculus also. So other years we may do some of that, but in this video we're going to focus just in on working with the calculator. Okay. You have looked at a number of ways to solve systems like this system that you're looking at here, the x plus 2y equals -2, 3x minus 4y equals 9. You've solved systems like this using multiplication and addition, also known as the elimination method, substitution method, graphing, graph both lines, see where they cross, things like that. And what we're going to do is work with this by rewriting this in terms of a matrix equation. Now, some things that I need you to notice here. First of all, notice that the coefficients here are 1 and 3, and notice 1 and 3. The other coefficients are 2 and -4. Notice the 2 and -4. Also notice the variables are x and y, and then finally the constants are right here. How about that? And there they are. Okay, so some things to look at. This first matrix is called the coefficient matrix. This next matrix is called the variable matrix. And then the other matrix is the constant matrix. And one of the things I need you to see here is that this is completely equivalent to that system that we were just looking at. And the idea is this is a 2 by 2 times a 2 by 1. And I get a 2 by 1 when I'm done. Notice that these match, and the outer numbers are the same as the answer. And if I do row 1, column 1, I'd have 1 times x plus 2 times y. 1 times x plus 2 times y equals -2. I would have for the second row, for the second row, first column, I would use the second row and the first column, and I'd have 3 times x, moving across and down, 3 times x plus -4 times y equals 9. So that would recreate that exact system. Okay? So let me just do a little clearing of ink here, just so we again know what just happened. Okay? So this times this equals this, and there it is. Okay? Same idea, this and this equals this. Okay? So in order to write a matrix equation from a system, the variables need to be lined up and they need to be in the same order. Okay? And you can go back and forth from one to the other. Okay? So what we're going to do next is do a little bit of back and forth. Okay? So the beauty of doing the matrix setup is that you can do a lot in a hurry. Okay? So notice that this is x, y, z. This is y. Oh, those don't match. Okay, so what I need to do is rewrite this so that everything follows the same pattern. So I'm going to follow this pattern x, y, z. So I'm going to keep the 2x, 3y, 5z equals the constant, the number without a variable. Okay, I'm going to do the same kind of thing for this. So I want the x's to come first. Well, I don't see any x's. Plus 3y minus 2z equals -3. Now what I did was I just moved this 8 by subtracting it from both sides. 5 minus 8 is -3. Okay, and that's an equal sign. Okay, and I'm going to do the same thing with the last one. So 3x minus 3y plus 0z equals 6. Okay, and then what I'm going to do is so I've set up the system. Okay, a system, remember, is just more than one equation. I've set up the system so that I can now write a coefficient matrix times a variable matrix equals a constant matrix. Okay, so this is the coefficients, this is the variables, and this is the constant. Okay, so here we go. 2, negative 3, 5. 0, 3, negative 2. 3, negative 3, 0. Okay, and then I need the variable matrix to be in the same order, because the idea is as I go across here, I would go down here. So it's going to be x, y, z, and then the constants just follow the same order like that. Okay, so this is the variable, I'm sorry, this is the matrix equation. Okay, this time I'm going to go backwards. Okay, so the idea is I'm going to be going across this row and down this column to equal that number. So negative 1 times A plus 2 times B plus 3 times C equals negative 6 is the first equation. Okay, and I'm going to do the same idea with the second row and the first column to get the second row, first column. So negative 2A, negative 3B, 5C equals 8. Okay, and last and definitely least, okay, whatever that means, 9A plus 4B plus 1C equals 2. And no, you don't need to write the ones, and you could have wrote a negative A on that first equation instead of negative 1A. But this is, write that matrix equation as a system of equations. So that's kind of going the other way. All right, so ultimately the goal is to be able to actually subtract, or to actually solve for A, B, and C. Okay, so we're going to take you through the whole process of that right here, and then maybe one more example depending on time. So I'm going to write that system just like I kind of did just a second ago. So this is going to be 1, 4, or this system is going to be written as a matrix equation. So here's the coefficient matrix. And everything's already X, Y, Z in order. Okay, don't be freaked out. That was just my phone ringing. And where are we at? 3, negative 5. Okay, the variable matrix will be X, Y, Z. Follow the same order. Equals, and the constant matrix, 0, 6, negative 13. All right, well, here's where the magic happens. I'm going to use some letters to represent these. So I'm going to call this matrix A, and I'm going to call this matrix B. And what's going to happen here is I'm going to multiply by matrix A's inverse on the left side on both sides. And so what ends up happening is this is all going to just cancel out, and what I'm going to be left with is XYZ equals whatever A inverse times B is, and that will be my answer. Those will be my answers for X, Y, and Z. Okay, so how are we going to do that? We're going to do that in the calculator. Okay, so where are you, calculator? There you are, calculator. Okay, and give me just a second. I gotta make some quick. Okay, so what I need to do right now is I'm actually going to type in those matrices, and again, I'm going to call this coefficient matrix, I'm going to call it A, and the constant matrix, I'm going to call it B. Okay, so here comes, so what I'm going to do is I'm going to go to matrix, and matrix is right above the x to the negative 1 key. Okay, and I'm going to edit, so I need to go under edit, and I'm going to hit enter to select that, or you can select 1. And the dimensions of that were 3 by 3. And notice how it's building out what looks like a matrix. Now I actually have written down on the board beside where I am what this matrix is, so I'm able to just kind of follow along, and if you have been taking notes then you'll be good as well. So all I'm doing is I'm typing the numbers and I'm hitting enter. So 2, enter, 1, enter, etc. Okay, Now the only real tricky thing is when I need to get out of this, I need to do quit. And quit is second mode, and mode is like right at the very top. I need to get out of this setup because if I try and edit a second matrix, what it'll actually do is try and put a second matrix inside my matrix, and I really, really don't want a matrix inside of a matrix. Okay, so now I'm going to go back to matrix. So again, second negative x to the negative 1. I want to go back to edit, which is, I did a left arrow, or you could do right twice, and I'm actually going to edit matrix B. Okay, so this time it's a 3 by 1, so a column matrix, and notice I just have a column of numbers. Okay, and you can either arrow down or just hit enter again, and it's 0, 6, negative 13. Okay, you really need to practice this, and yes, you need to be able to do this. Second and quit, again, second mode is quit. And now this is where the excitement comes in. Remember what I need to do here is A inverse times B. Well, you pretty much type it in like you see. Okay, so I'm going to go back to matrix. So second x to the negative 1. I need the name of A, so I'm just going to push 1 or enter. And I want to do the multiplicative inverse. Well, that is x to the negative 1. This is how it looks right now. Times, well, I don't think I need to hit times, but I'm going to anyway, matrix B. So again, second and x to the negative 1, and this time I want matrix B. So A inverse times B is 3, negative 0.5, 0.5. Okay, so those are those values. So I'm going to just pop back over to my screen here, my other screen, I think. There we go. So 3, negative 0.5, 0.5. Well, so at some point now we need to say what those things are. So x is 3, y is negative 0.5, and again, if well, not again, but if you'd prefer to write it as a fraction, you certainly may. Doesn't really matter to me. So we just solved a 3 by 3 system in one shot. Okay, now let me make a big stink here. Everything you see written here needs to be written. Okay, I need to have that matrix equation. I need to have the assignment of what we named them, unless you're going to rewrite them over and over again. So I need to have like which one's A and which one's B and all that kind of stuff. And then I need to see this work where I am multiplying by A inverse. Now let me make a big stink out of this. Remember, matrix multiplication is not commutative. In other words, if I write it in the wrong order, I'm not doing the same thing. So this A inverse must be on the left side of the B. This A inverse must be on the left side of the B. Okay, so that's a big deal. Okay, so everything you see written up here, except for all the circle-y boxes and all that stuff, needs to be here. Okay, let's just do one more example, and we'll kind of move this along. Now, worth noting that I actually see 4 variables floating around in here. Now, I think they're all in the same order, but you need to be careful because some of these equations don't have all 4 of them. So like I see 2, let me make just a little bit more room here. All right, so 2, 1, 2, 0, because I need a room for a W here. Okay, so the way this is going to go is X, Y, Z, W. Okay, I'll go ahead and fill in the constant matrix here, even though that seems a little close. Okay, 10, negative 1, 39. Okay, so X, Y, Z, W. So 3, 2, negative 1, negative 1, and I'll stop saying all the numbers as I write them. There's no Z in this one. No Z. Tell me your business. No. Okay, and they need to be in the correct order from left to right, X, Y, Z, W. Okay. Now, if you decide that you're going to rearrange everything to put W before, you know, W, X, Y, Z, I understand that, but you're going to have to adjust your variable matrix when you do it. Okay. Now, I'm going to write down what needs to be written down. Okay. I'm going to call this matrix A. Now, you can do it without the brackets if you want. If you want to just write A here and B here, that's fine. Now, what's going to happen then is as I do A inverse on the left side, on each side of the equation, this cancels out, leaving just the variable matrix equals that. So I'm going to write this x, y, z, w equals A inverse times B equals, and then we'll have some numbers here, and then we'll have to interpret what we just found. Okay? Okay, well, let's pop over to the calculator, and I'm just going to replace my matrix A and my matrix B. I just tend to always use matrix A and matrix B, and this time matrix A is a 4 by 4, and you can just keep typing and it'll run right over. Okay, and unfortunately it runs off the screen, but it'll keep moving things back and forth. Okay, and again, I just am looking at notes that I made about the stuff that we did on the last screen. Okay, almost done with this one. Okay, I'm going to quit, so second in mode. I'm going to go back to matrix again. I'm going to edit again. I'm going to go to B again in that order. And I know you know if I'm moving too fast that you know how to hit pause. You are in control of this thing. I am not. I'm not even there. I mean, I'm with you in spirit, whatever that means. Okay, so I have my two matrices in. And now again, what I'm actually going to be typing in is A inverse times B. Okay, so I'm going back to matrix. I'm picking that name, inverse times B. You probably don't need to type times, but I'm going to do it just to be safe because I know it works. And hit enter. Okay, so that's what we got so far. Okay, so just a quick reminder of what you just found were the values of x, y, z, and w. And those are the values that make all four of those equations true at the same time. Those are the values that if I put those things in, all right, so let me just make a quick list and then I'll keep talking my stuff like I have been. Okay, 4, -2, 1, 3. Okay, so the solution of an equation is just the value that, or values that make it true. Okay, so the solution to a system is the values of the variable that would make all of these equations true. So if I put 4 in for x, like right there, if I put y is -2, if I put z is 1, and w is 3 in there, by the time I got done doing this total, I should get 39. So, you know, it's one of those things where if you wanted to go back and kind of double check yourself, you'd see that it worked, you know, by plugging those values in. Okay. One other quick little note to self. All of the stuff we've done in the calculator here, you can do the same kind of thing just for adding and subtracting and multiplying and things like that. So for instance, if you wanted to come in here and make a little, let's say it was a 4 by 2, then I'm just going to kind of play with stuff because I just want a matrix in here. So you could do A times B if you wanted. This doesn't solve a system of equations. Whoop, sorry. Clear. So I could do like matrix A times matrix B, and it'll do the calculations for me. Or I could do matrix B times matrix A. It'll do the calculations for, oh yeah. Okay, so it even knows that the dimensions have to work a certain way. Okay, all right, so I'm leaving it at that. This is solving systems of equations using inverse matrices. This is in section 7.3 of our book. It is not in there, I'm sorry, it is not the only thing in section 7.3, but it is the only thing that we're going to deal with right now. Okay, all right, so thank you very much for watching. Thanks for hanging with SanfordFlipMath, and we'll see you in class. Bye.